Apple's new Mac Pro. Whether you love it or hate it, its journey so far has been an interesting one. As a PC guy myself, I've got to give a hats off to Apple for making a computer tower that's just so unique and well refined and just overall so different from our typical PC tower. In fact, there's a lot that the enthusiast PC market can learn from Apple's design. But one thing that has stuck with me throughout all of the reviews that I've watched of the 2019 Mac Pro is Apple's approach to airflow and fan speed. Specifically, those three big fans at the front of the case supposedly spin at different speeds, and the reason for that is so that each individual fan will be producing a different noise frequency or pitch, as opposed to amplifying the noise level at a single pitch. If this is correct, that means that you could potentially get practically the same airflow and thermal performance, but at much quieter operation. And I couldn't help but think if this approach to airflow was so genius and magical as some of the reviews were stating, why hasn't the PC community done something similar? I mean, it's just physics after all. Apple doesn't own this kind of style of airflow approach. I'm really interested to see whether we can replicate very similar results with a very similar airflow structure as the Mac Pro, or perhaps this is just a bit of marketing fluff. So just to recap here, the idea here is that if you have multiple fans in your PC, it's better to have them run at different speeds as opposed to the same speed, as that way you're able to avoid them amplifying a single noise frequency. If this is true, we could potentially see better noise performance from our PCs at higher load, definitely useful for a workstation or high performance gaming rig. On paper, it sounds pretty convincing as well. We're pretty familiar with what multiple sound sources at the same noise pitch could sound like, and so avoiding that amplification is the goal here. The thing is though, this goes against the traditional way of controlling multiple fans in your system, where you'd usually connect them to splitters or a fan controller, and then a single PWM or DC fan header on your motherboard that would set them at the same speed. To try Apple's approach on your own system, you'd need one fan header per fan that you'd like to run independently. Another approach to this stepped fan RPM would be to use your common splitters or a controller, but also adapters with resistors built in to lower the fan speed. Now, before we dive into the testing, I'll first say that I don't know what Apple's exact approach to this airflow strategy is, so I am basing this solely just off the very popular reviews that I've seen online talk about this quite consistently. So I don't know the exact deltas between the fans that are running here, and I don't know what the stepping is, but we will dive into that in just a second, and we have tested quite a few different configurations. The main focus though will be comparing them at the same RPM to one of the fans slightly slower and one of the fans slightly faster. For example, comparing all fans at 1200 RPM versus one at 800, one at 1200, and one at 1400. The test system that I've set up here is in the Fractal Design Define 7, a pretty large mid-tower case with a ton of volume inside. If you want to build a workstation that's similarly spec'd to the Mac Pro but on the PC side of the fence, this case really is a solid choice. It's also got quite a bit of sound dampening material behind the panels, excellent if you're looking to build something nice and quiet. So 3 front mounted fans for intake, just like the Mac Pro, and the only other fan in the system contributing to the noise are on the Noctua cooler for our Threadripper 3970X, but those are spinning at just 500 RPM for all tests. So let's answer the first question of this little experiment, and that's that, do fans actually create a higher pitch the faster that they spin? Because we know that fans do get louder the faster they go, that's pretty obvious, but do they necessarily create a higher pitch as well? And the answer to this is yes, at least for the Noctua NF-F12s that we're testing here, which have a fairly similar sound profile to most static pressure fans that I've tested in the past. So along the x-axis of this graph, we have the sound frequency, so lower pitches to the left and higher pitches to the right, and on the y-axis we have the sound level. The absolute values here don't really matter, seeing as that depends entirely on the gain set by the microphone and the recorder. The accurate peak noise level readings can be seen off to the right there. So with all of the fans spinning at 800 RPM, we get a quiet low hum at 94 Hz. Bumping that up to 1000 RPM raises the frequency to 117 Hz. 1200 RPM generates a peak frequency of 141 Hz, and at 1400 RPM we see 2 peaks at about the same level, 164 and a much higher pitch, 328 Hz. Here's a quick sound test of these before we move on to comparing this to Apple's stepped RPM approach. But now let's compare this to the stepped RPM approach, where none of the fans are set to the same RPM. The theory here is that by doing this, they can avoid amplifying the same single sound pitch. So here we're comparing 800 RPM on all of the fans to one at 600, one at 800, and one at 1000. The conclusion here is that although the slightly faster fan is running at a different pitch, it's just plain and simple louder, making the stepped RPM configuration the louder and higher pitch option every single time. We see this again in our other two tests comparing the pitch and noise levels between fixed and stepped. The stepped RPM fan configuration is always louder thanks to that single faster and louder fan. And then I thought maybe this just wasn't Apple's approach at all, and instead maybe they've just been reducing fan speed altogether and by lower margins. So now let's compare 1200 RPM fixed to one at 1000, one at 1100, and one at 1200. And of course that stepped fan RPM configuration is running quieter because the fans overall are running slower. This is a no-brainer, slower fans are quieter, and that's why I didn't plan on testing it in the first place. One argument could be that, sure, the stepped approach is quieter because it's running slightly slower, but also because it's running at different frequencies. There could be other noise benefits by running slightly different fan RPMs too, seeing as the velocity of the air from each fan will be slightly different. It might produce a more natural and organic interference between one another, but that's descending into an entirely different rabbit hole. For now, I'll leave you with a sound test between them. So to wrap things up, I'd say that stepped fan RPMs may be beneficial for a system with multiple fans that are close to each other, but I'd really need to do a lot more testing to say for sure. If you have an expertise in aerodynamics, I'd love to know your thoughts on this topic down below, because I sure do not. But taking a step way back, I think there's a lot more effective factors that make Apple's Mac Pro as quiet as it actually is. Things like a pretty solid power management for the CPU and the pretty beefy GPUs, and also a huge heatsink design for both the CPUs and the GPUs that are designed around a slow, steady stream of airflow. That's something that we are yet to see in the PC market. There's also a fairly solid chance that those Xeon W chips, even the 28 core, are running with a fairly restrictive power target and at low voltages as well, but without a Mac Pro here, I can't really say for sure. So maybe this whole fan control situation is a little genius from Apple, or maybe it's just a bit of marketing fluff. The results here are certainly a bit mixed, and I certainly couldn't prove anything revolutionary, but I would love to know your thoughts and comments down below. As always guys, a huge thanks for watching, and I'll see you all in the next one.